Welcome back friends. Welcome back to another video session from this channel. So in this video session we will be studying regarding the transcription mechanism or the transcription process. Is it okay? So what is transcription or how we can define the term known as transcription? So the specific mechanism, the specific process through which the double-stranded DNA it is capable to yield or it is capable to synthesize a single-stranded RNA, it is nothing but what? Transcription. So according to the central dogma of molecular biology, when a particular gene, when it undergoes expression, it is capable to yield a single-stranded RNA. So the specific mechanism or the specific process through which the double-stranded DNA it is capable to yield or it is capable to synthesize a single-stranded RNA, it is nothing but what? Transcription. Is it okay? So let me write it here. So if we consider one particular gene, is it okay? So what is gene or how we can define the term known as gene? Gene is a segment of DNA. So if we consider one particular chromosome, within the chromosome the genetic material is packaged, right? Or the genetic material is embedded. So the specific genetic material which is embedded or which is packaged inside the chromosome, the specific genetic material which is nothing but the DNA, it possesses a tiny segment or a tiny component. So the tiny segment or the tiny component of the DNA, it is nothing but what? Gene. So when a particular gene, when it undergoes expression, is it okay? When a particular gene, when it undergoes expression, it synthesizes a single-stranded mRNA. So the specific mechanism, the specific process through which a particular gene, it is capable to yield or it is capable to synthesize a single-stranded RNA, it is nothing but what? Transcription. Is it okay for you? So let me write it here. Expression, right? So it is capable to synthesize a single-stranded RNA, which is nothing but the mRNA. Is it okay? So the specific mechanism or the specific process, it takes the advantage of an enzyme which is nothing but what? RNA polymerase. So by taking the advantage of an enzyme known as RNA polymerase, the double-stranded DNA it is capable to yield or it is capable to synthesize the single-stranded mRNA. So here the specific RNA polymerase enzyme which plays a prominent role for organizing the transcription mechanism in case of prokaryotes, it do not possess any different types. But the specific RNA polymerase enzyme in case of prokaryotes, it possesses or it consists of different subunits. So what are the different subunits of RNA polymerase here? So the different subunits of RNA polymerase in case of the prokaryotic transcription, it consists of alpha 1 and alpha 2, beta 1, beta 2 and the omega. So here all these are the various subunits of RNA polymerase, and in addition to these subunits, the RNA polymerase enzyme it also possesses a specific factor which is nothing but what? Sigma factor. So by taking the advantage of a specific factor known as sigma factor, RNA polymerase enzyme it is capable to recognize the promoter region which is a part of the double-stranded DNA. Is it okay? So here we need to understand one key point. The transcription mechanism or the transcription process in case of prokaryotes, it occurs in the cytoplasm. In case of prokaryotes, both transcription and as well as translation, it occur in the cytoplasm. But whereas in case of eukaryotes, transcription mechanism it occurs in the nucleus, and whereas translation it occurs in the cytoplasm. And here the specific transcription mechanism which occur in case of prokaryotes, it is not so vast or it is not so complicated, because in case of prokaryotes the genome complexity is not so vast, right? Or it is not so huge. So the reason why for organizing the transcription mechanism in case of prokaryotes, the specific mechanism or the specific process, it do not take the advantage of many other enzymes or many other factors. Is it okay? So this is regarding the transcription mechanism or the transcription process in case of prokaryotes. So once when the single-stranded mRNA, when it has got successfully synthesized during the transcription mechanism or the transcription process, now the specific mRNA, it is ready to participate in the translation mechanism or in the translation process. for the successful synthesis of the polypeptide chain. Is it okay? So this is regarding the prokaryotic transcription. And right now we are going to study regarding the eukaryotic transcription. So what are the various consequences which are in association with the eukaryotic transcription mechanism? Is it okay? So let me write it here. So let me erase the things first. So in case of eukaryotes, transcription in case of eukaryotes. Is it okay? So as I have already mentioned you, transcription mechanism or the transcription process in case of eukaryotes, it is much more complicated in comparison to the transcription mechanism in case of eukaryotes, because in case of eukaryotes the genome complexity is too vast or it is too huge. So the reason why for organizing the transcription mechanism in case of eukaryotes, the specific mechanism or the specific process, it takes the advantage of too many factors. So by taking the advantage of too many factors, the transcription mechanism or the transcription process in case of eukaryotes, it is successfully organized. And in addition, as I have already mentioned you earlier, the specific key enzyme which play a prominent role for organizing the transcription mechanism in case of eukaryotes, it is nothing but what? RNA polymerase. The RNA polymerase enzyme which is used in case of prokaryotic transcription, it do not possess any different types. The RNA polymerase enzyme itself, it possesses only different subunits. But whereas in case of eukaryotes, the RNA polymerase enzyme, it possesses different types. So what are the different types of RNA polymerase which are used in case of the eukaryotic transcription? So the different types of RNA polymerase include RNA polymerase 1, polymerase 2 and polymerase 3. Is it okay? So let me write it here. So let us assume it is a gene, and when it undergoes expression, it is capable to yield or it is capable to synthesize a single stranded mRNA. Is it okay? And here, in order to organize the transcription mechanism in case of eukaryotes, the transcription mechanism or the transcription process, it takes the advantage of three different types of RNA polymerases. These include polymerase 1, polymerase 2 and polymerase 3. Is it okay? So let me write it here. Polymerase 1, polymerase 2 and polymerase 3. So by taking the advantage of these three different types of RNA polymerases, the RNA synthesis in case of eukaryotes, it is successfully organized. For the successful synthesis of rRNA, RNA polymerase 1 is used, and for the successful synthesis of mRNA, polymerase 2 is used, and for the successful synthesis of tRNA, polymerase 3 is used. Is it okay? And in addition, the transcription mechanism in case of eukaryotes, it takes the advantage of too many other factors, too many other remodeling factors for the successful organization of transcription in case of eukaryotes. Because for organizing the transcription mechanism in case of eukaryotes, too many factors are required. In case of eukaryotes, the genome complexity is too huge or it is too vast in comparison to the prokaryotic transcription. And here we need to understand one key point. As I have already mentioned you, in case of prokaryotes, both transcription and as well as translation, they occur in the cytoplasm. Is it okay? But whereas in case of eukaryotes, the scenario is quite opposite. In case of eukaryotes, transcription mechanism, it occurs in the nucleus, and whereas translation, it occurs in the cytoplasm. Is it okay? So let me explain here. So let me erase the things first. So let us assume it as the nucleus. Is it okay? And here It is nothing but what? Cytoplasm. So here the mRNA which has got successfully synthesized during the transcription mechanism or in the transcription process, it has to export from the nucleus to the cytoplasm for participating in the translation mechanism or in the translation process. But prior to that, prior to the exporting of the eukaryotic mRNA from the nucleus to the cytoplasm, the specific eukaryotic mRNA, it has to undergo certain modifications and certain processing events, as I have already mentioned you in my previous video session. So these processing events and these modifications, they are nothing but what? 5' capping, 3' tailing and the processing event. Is it okay? So let me write it here. So let us assume it has the 5' end of the mRNA and it has the 3' end. So here, so let me write it here, 5' capping. Is it okay? And the next one is 3' tailing, processing. So here, prior to the exporting of the eukaryotic mRNA from the nucleus to the cytoplasm, the specific eukaryotic mRNA, it has to undergo the 5' capping and as well as 3' tailing. So at the extreme 5' end of the eukaryotic mRNA and methylated guanosine nucleotide, it is successfully recruited here. Is it okay? So let us assume it as the methylated guanosine nucleotide, which has got successfully recruited at the extreme 5' end. And in addition, at the extreme 3' end, multiple adenosine nucleotides are recruited here. Is it okay? Multiple adenosine nucleotides are successfully recruited here. Is it okay? So here, in addition to 5' capping and 3' tailing, the specific eukaryotic mRNA, it has to undergo the processing event, because in case of eukaryotes, the specific eukaryotic mRNA, it not only possesses the coding sequences, and in addition, the eukaryotic mRNA, it also possesses the non-coding sequences or the introns. So these non-coding sequences or introns, they do not have any prominent role in organizing the translation mechanism. So the reason why prior to the participation of the eukaryotic mRNA in the translation mechanism, the non-coding sequences or the introns, they undergo successfully spliced out by the means of a specific mechanism or by the means of a specific process, which is nothing but what? RNA splicing. Is it okay? So this is regarding the eukaryotic transcription mechanism or the eukaryotic transcription process. So likewise, the translation and the replication, the transcription mechanism or the transcription process, it can be explained or it can be studied under 3 different phases, and these include initiation, elongation and termination. So which we are going to study, which we are going to learn in the next upcoming video session. So this is regarding the introduction of transcription in case of prokaryotes and as well as in case of eukaryotes. I hope that this video will help you a lot. So if you like this video, just hit the like button and share it to your friends. And I remember you people to subscribe my channel for getting more and more videos what I make day to day. Thank you.